We have g of x is equal to 5x plus 2. Okay, and we want to know which is the largest integer value of x such that f of x is less than or equal to g of x. Okay. In order to tackle this problem, we're going to have to create a table. Okay. So let's go ahead and do that, and give me just a moment while Ms. Herman finds her nice, neat table that we created a little earlier here. Oh, we're not unorganized. Oh, there it is. All right, so it says two functions are shown below. Here's the problem again, just in case we missed it. So I'll give you a second to look at it. Okay, so we're going to start with creating a table, evaluating each equation for the x value in our table to get the y. Okay, so remember f of x, the equation was 1/2 times 2 to the x power. Okay, so if our x value is 0, I'm simply going to plug in 0 everywhere I see x. Okay, and when we evaluate it, we end up with 1/2 times 1. Well, why is that? Anything to the 0 power is going to be 1. It doesn't matter if it's 2, 3 million, 1,000, any number to the 0 power is going to be 1. Okay, that's the rule. So 1/2 times 1 is 1/2. Okay. We're going to do the same thing for g of x. Well, remember what our equation was for g of x. It's 5x plus 2. So every place that I see x, I'm going to enter in 0. So 5x plus 2. So 5 times 0 plus 2. Well, anything times 0 is simply 0. So 0 plus 2, and our final answer would be 2. Okay. So notice f of x is less than or equal to g of x. But remember, we're looking for the greatest value of x according to the question. So we'll keep going. We'll go ahead and plug in 1. 1/2 times 2 to the first is going to be 1/2 times 2. That yields 1. Okay. Next we have 5 times 1 plus 2. Well, 5 plus 2 is 7. We're going to plug in the value of 2. Okay, we're going to just keep going until we find a place where the f of x and g of x are equal, okay? Because that is going to be the place where it is, which would satisfy the question according to the EOC. So for x equals 3, we're going to type in 1/2 times 2 to the third. Well, 2 to the third means 2 times 2 times 2, which is 8. Okay. 1/2 of 8 is going to be 4. If we simply enter in 3 for x at 5 times 3 plus 2, we end up with 15 plus 2, which is 17. Notice that f of x is still less than g of x, so that is definitely one part of the solution, but it's not the largest value of x, which would satisfy the problem. Looking at 4, if we fill in 1/2 times 2 to the 4th power, well, 2 to the 4th power is going to be 16 because it's 2 times 2 times 2 times 2. Well, half of 16 is 8. Going over to g of x, evaluating that for 4, that's 20 plus 2, so 22. At 5, 2 to the 5th is equal to 32, so 1/2 of 32 is going to be 16. 5 times 5 is going to be 25 plus 2 is 27. Let's go ahead and look at 6, okay? I know the process might seem tedious, but remember this is calculator inactive, so we have to make a chart to keep it organized on what we've tried, okay? For 6, we have 1/2 times 2 to the 6th. Well, 2 to the 6th is going to be 64, okay? 64 divided by 2, or 64 times 1/2 is 32. If we fill in 6 at 5x plus 2, that's going to be 5 times 6, which is 30 plus 2. Well, that's 32. At this point, f of x and g of x are equal. Okay. Remember, the problem said that it wanted us to find the largest integer value of x such that f of x is less than or equal to g of x. Okay. Up until 6, f of x has been less than, okay? But at 6, it becomes equal to, okay? Just to be sure that there's not another value, we're going to go one step further and try 7. And if you notice at this point, f of x evaluated for 7 becomes larger than g of x evaluated at 7. So I know that I can stop at 6, and I would simply fill in 6 on my EOC.